Every single night you drive your car, you are trusting your headlights with your life. You assume the bulbs inside those housings are giving you the best possible visibility. You assume the light reaching the road ahead is as good as modern technology allows. And you assume that whoever sold you those bulbs was being honest about what you actually needed. Most drivers are wrong on all three assumptions. A Japanese automotive lighting engineer with 16 years of headlight system testing experience on Toyota, Honda, Nissan, and Mazda vehicles recently completed a comparison study that completely changed how thousands of Japanese car owners think about their headlights. He tested LED and halogen bulbs across identical Japanese vehicles under identical real-world conditions: night highway driving, rain, fog, and urban stop and start traffic. He measured light output, beam pattern accuracy, heat generation, lifespan, and actual road illumination at distances that matter when something unexpected appears in front of your car at speed. The results destroyed several assumptions that the headlight industry has been profiting from for years. And the drivers spending the most money were not always getting the best protection. Before the results, you need to understand exactly what separates these two technologies. Because most drivers make their headlight decision based on price or appearance without understanding what actually happens when light leaves the bulb and reaches the road. A halogen bulb works by passing electrical current through a tungsten filament inside a gas-filled glass capsule. The filament heats to extreme temperatures and produces light as a byproduct of that heat. Halogen technology has been in automotive use since the 1960s. It is simple, reliable, and the entire lighting system of every Japanese car produced before the mid-2000s was designed and calibrated specifically around halogen light output, beam angle, and color temperature. The reflector housings, the projector lenses, the beam cut-off lines, all of it was engineered with halogen as the light source. An LED bulb works entirely differently. Light-emitting diodes produce light through electroluminescence, electrons releasing energy as photons when passing through a semiconductor material. No filament, no heat as the primary byproduct. The light is produced directly and efficiently. LED bulbs consume significantly less power, produce significantly less heat at the bulb itself, and last dramatically longer than halogen under ideal conditions. On paper, LED wins every comparison. In real-world Japanese car applications, the situation is far more complex, and this is where the testing results become genuinely important for your specific vehicle. The first test measured raw light output. LED bulbs produced between 300 and 500% more raw lumens than standard halogen equivalents. Every LED manufacturer uses this number in their marketing, and it is accurate. What they do not tell you is what happens to those lumens when they leave a housing designed for halogen. The reflector and projector housings in your Toyota Corolla, Honda Civic, or Nissan Sentra were designed to take halogen light, which comes from a single-point source at a specific position in the housing, and direct it precisely onto the road in a controlled beam pattern. The beam cut-off line, the width of illumination, the distance of projection, all of it depends on light originating from a specific point at a specific angle. LED bulbs produce light from multiple diode chips arranged around the bulb body. The light source is not a single point. It is distributed across multiple positions simultaneously. When this distributed light source is placed inside a housing designed for a single point source, the reflectors and lenses cannot direct it correctly. The result is scattered light, bright in some areas, creating dark spots in others, with significant light scatter upward into oncoming traffic. The Japanese engineering team measured beam pattern accuracy using standardized road illumination testing. Halogen bulbs in their original housings produced beam patterns within 3% of design specification. LED retrofit bulbs in the same halogen housings produced beam patterns with 40 to 60% deviation from design specification, depending on the specific LED product tested. The road directly ahead was adequately illuminated. The peripheral zones, where pedestrians, cyclists, and road hazards appear, showed significant dark areas that the halogen beam had covered correctly. This is the test result that the LED upgrade industry does not want posted on the box. The second test measured oncoming driver glare. This is the safety issue that matters most beyond your own visibility. Scattered LED light in halogen housings produces significant upward light scatter that hits oncoming drivers directly at eye level. The engineering team measured glare intensity at oncoming driver eye height across 30 meters of approach distance. LED retrofits in halogen housings produced glare readings between 200 and 350% higher than halogen originals in the same housings. Several LED products tested produced glare levels that exceed legal road safety standards in Japan and across most of Europe. You are improving your own visibility slightly while significantly impairing the visibility of every driver coming toward you. On a two-lane road at night, that trade-off has direct safety consequences that no amount of marketing language about superior lumens addresses. The third test measured actual useful road illumination, not raw output, not beam pattern accuracy, but the specific area of road surface that was usefully illuminated for the driver at real highway speeds. At 100 km per hour, a driver needs approximately 100 meters of clearly illuminated road ahead to have adequate stopping distance for unexpected hazards. The testing measured illuminated road length and width at this speed across both technologies. Halogen in original housings illuminated 94 meters ahead with consistent coverage across the full lane width and adequate peripheral coverage into road shoulders. LED retrofits in halogen housings illuminated 108 meters at the center of the beam, but showed significant drop-off at lane edges and created the scattered peripheral pattern documented in the beam test. The center distance advantage of LED was real. The peripheral coverage loss was also real. For straight highway driving, the LED advantage was measurable. For the moment a pedestrian steps off a curb at the edge of your beam, halogen coverage was more consistent. Now the results change completely when LED technology is matched with purpose-built LED housings. Japanese vehicles produced from approximately 2012 onward with factory-fitted LED headlight systems use housings specifically engineered for LED light sources. Projector lenses with sharp cut-off lines designed around LED diode positioning. Reflector geometry calculated for distributed LED output. Thermal management systems built into the housing to handle LED heat at the driver electronics rather than at the bulb. On these vehicles, LED technology delivers every advantage the marketing promises. Better distance, better peripheral coverage, better wet weather performance, lower power consumption, dramatically longer service life. The Toyota RAV4 from 2019 onward with factory LED headlights. The Honda CR-V from 2017 with available LED system. The Nissan Qashqai LED variant from 2018. The Mazda CX-5 with LED from 2017. These vehicles have housings built for LED and the technology performs as advertised in those applications. The critical question for every Japanese car owner is therefore not LED versus halogen in general. The critical question is whether your specific vehicle has housings designed for the light source you are using. If your vehicle was manufactured before 2012 and came from the factory with halogen headlights, your housings were designed for halogen. Retrofitting LED bulbs into those housings produces the scattered beam, peripheral coverage loss, and oncoming glare problems the testing documented. You are spending money to create a safety problem you did not previously have. If your vehicle was manufactured after 2012 and came from the factory with LED headlights, your housings were designed for LED. Replacing factory LEDs with aftermarket LED equivalents of equal or better specification maintains the performance the system was designed to deliver. Downgrading to halogen in an LED housing produces equally poor results in the opposite direction. If your vehicle came from the factory with halogen, but you want genuine LED performance, the correct solution is complete headlight housing replacement with units specifically designed for LED, not bulb retrofitting into halogen housings. This costs significantly more than a bulb swap, but delivers the beam pattern accuracy and safety performance that LED technology actually offers when matched with appropriate optics. The cost reality across the full ownership period makes the correct choice clearer than the upfront price suggests. Standard halogen bulbs for a Toyota Corolla, Honda Civic, or Nissan Altima cost between $8 and $25 per bulb depending on brand and specification. Average service life is 450 to 1,000 hours of use. For a driver using headlights 2 hours per night, the replacement interval is roughly every 2 to 4 years per bulb. Lifetime cost over 10 years of ownership, approximately $80 to $150 in bulbs plus labor if workshop fitted. Quality LED retrofit bulbs cost between $25 and $80 per bulb with advertised service lives of 30,000 hours or more. The service life claim is genuine under ideal conditions. However, in halogen housings the scattered beam and glare problems exist regardless of how long the bulb lasts. You are paying more for a bulb that lasts longer, while performing less safely in the housing it was not designed for. Factory equivalent LED replacement bulbs for vehicles with original ID systems cost between $40 and $120 per unit with genuine long service life and correct beam performance. For these vehicles, the higher upfront cost is justified by both performance and longevity. The Japanese engineering recommendation from the full study was direct and specific. Never retrofit LED bulbs into halogen housings regardless of the lumen claims on the packaging. The housing determines the beam pattern, not the bulb. Maintain halogen in halogen housings and replace on schedule. Use LED only in housings specifically engineered for LED light sources. If upgrading older Japanese vehicles to genuine LED performance, budget for complete housing replacement, not bulb swapping. One additional finding from the study that most drivers never consider: halogen bulbs degrade gradually over their service life. A halogen bulb at 80% of its rated life is producing approximately 20% less light than a new bulb. Most drivers never notice this gradual reduction because it happens slowly over months and years. The engineering team found that many Japanese vehicles in daily use were running halogen bulbs at 60 to 70% of new output, simply because the driver had never replaced bulbs that had not yet completely failed. Replacing halogen bulbs proactively at the manufacturer service interval, rather than waiting for failure, restores full designed beam performance at minimal cost and significantly improves night driving safety without any technology change at all. Your headlights are the single most important safety system on your car after the brakes. Not the most expensive system, not the most technologically impressive system, the most directly connected to whether you see what is in front of you before it is too late. Spending money on the wrong upgrade while the correct maintenance goes undone is exactly the kind of decision that costs drivers far more than the money they thought they were saving. Know what your housing was designed for. Match your bulb to your housing. Replace on schedule before degradation becomes a safety issue. And understand that the most expensive option is not always the safest one when the engineering behind it does not match the vehicle it is fitted to. If this video changed how you think about your headlights, hit like right now and share it with every Japanese car owner you know. Subscribe for more insider knowledge that protects your car and your safety. Comment below with your country and the next car topic you want me to cover. I read every single one. See you in the next video.